As a person who has done quite a bit of work in model risk assessment, model validation, and evaluation, and created libraries for these kind of things in the past, tell us a little about your point of view and why is this important to talk about?
As engineers working in large organizations, there are many blind spots and silos happening in the organization. PMs don't talk to engineers, engineers do not talk to customers. There is always barriers between different teams. When it comes to a use case, it's very easy to get into the trap of only thinking about the performance of a model in a silo. What we finally care about is what customer is using and what customer sees. That shouldn't be the focus, to see how performant is the search, how performant is the LLM. The combination and the user experience is the most important thing. That's why I like the validation versus evaluation. We focus on evaluation a lot, and then we lose sight about what you call validation.
Makes a lot of sense. We've been seeing a lot of LLM guardrails coming out. Where do guardrails fit into this discussion?
If there are things that are not up to a certain standard, you shouldn't output them. For example, for our case, we have some internal knowledge base that we know certain things to be true. If the output of the LLMs is not going to be correct, then we have guardrails because LLM is going to keep on changing. We have seen where same prompt, same temperature, same everything still outputs a different thing. So having some sort of either logic-based, statistical-based, lexical-based, or even another LLM to do verification at the using time would be guardrails.
One of the comments that you made that I really liked was that you should think about metric-driven development when it comes to systems like this. Essentially, start by the simplest system in terms of implementation and also measuring how it performs, and then slowly add more complexities to it. How does that idea relate to what we are discussing here?
That's a great question, actually. The good and the bad thing here is metrics are hard to define and they're always not going to be perfect, but that shouldn't stop you from trying. Even in previous NLP work, when people started working on machine translation, there used to be metrics like blue, rouge, which are not perfect, but help you determine the extent to which the system works. Now, the great thing here is because you have new tools to do evaluation, you have LLM, you can create programs, and you have access to all these different types of data. The power is back to you to think about the users and craft innovative metrics that apply just to you.
Coming back to Percy, your PhD research is on formal verification of software systems. Obviously, LLM-based systems is going to be part of it. For those of us who are closer to the cutting edge of what is happening, what scenarios can you imagine where I have to start thinking about formal verification?
Formal verification sounds scary, but it's actually broader than what people think it is. When we talk about formal verification, most of the time I think we do all those mathematical tricks and get something of some property of the neural network. If the model is too complex, you try to use a smaller model to simulate the larger model, and then you can verify properties of the smaller model and hopefully transport to the larger model. In real world, most of the time we don't need it, which is actually a good thing because it's very expensive and takes a lot of time to develop. But if we absolutely care about one aspect of the system, then maybe we want to start to think about it. You have some legal requirements about the safety or bias of the model, and you have to absolutely get that right. It can also be a thing to showcase what your model is capable of. For example, if you're fine-tuning a large model, we can showcase the robustness. We have different ways to do formal verification of this, and you can show your large model will not only perform very nicely on the input, but it will also perform very consistently a diverse set of inputs. What's really valuable about the formal verification is also that a lot of the time we understand different properties under restricted environment, for example, helping analyze internal behavior of the neural network and find that maybe remove all those neurons from the large model and it actually improve the performance.